Hello and welcome back. Here we are with some homework questions from week 3, the MyMathLab homework. And one that I chose is question number 7. The reason I chose this one is because this is just slightly different than what I did in the lecture. And it's not very much work, but let me just show you. So first thing I need to do is I'm going to add e to both sides. So it's then going to say e to the 6x plus 6 equals e. And the reason that I'm doing this one is because when you just have an e and you go, hey, wait a second, there's no exponent there. Well, e to the 1 is the same thing as e, so that means that the exponent is 1. Now that the bases are the same, we don't need those anymore, so you can just eliminate those and say that the exponent on the left has to equal the exponent on the right. And then solve for x. So you could subtract 6 from both sides, and that's going to leave 6x equals a negative 5. And then divide both sides by 6. And it looks like we get the answer that x equals negative 5 over 6. And whenever they have this part, make sure you pay attention. Type a fraction or a whole number. Use a comma, and then this is if you got multiple answers. Like if you got 2 answers, then put a comma in between. But it's saying just put the fraction, so you just type in the fraction, and that one's done. Then on to the next one, which I chose number 11. So this is the finance type problem, the compound interest. A person wishes to have $28,800 cash for a new car 7 years from now. So this is using the compound interest formula that I did in the lecture part, but they're doing it in a slightly different way. So we use the compound interest formula. And what they're saying is in the future, they want to have this A be the $28,800. $28,800. And we don't know how much should be placed in the account now. So this is just going to be capital P. And then the interest rate is 4.7%. So the 4.7 needs to be changed to a decimal. So move the decimal 2 places to the left. So that's going to be a 0.047. So 1 plus the 0.047. And then compounded weekly. So how many weeks in a year? There's 52. So that means that the n equals 52. And finally, they said that it's going to be 7 years. So put a 7 right there. And then to solve for p, I just need to divide both sides by this. So I'm just going to go ahead and do it on the calculator. Take this number divided by all of this. And I'm not even going to simplify this. I'm going to type it in the calculator exactly like that. So to begin with, we have 28,800 on this side. And then divide by all of this. So divided by, and then put the parentheses, 1 plus 0.047 divided by 52, and then the exponent is a 52 times 7. And so that means that if you want $28,800 7 years in the future, right now you should go down to the bank or bring out your phone and put in the bank $20,728. $20,728, and then this would be need to be rounded to 80 cents. And then do pay attention to this. They said round it to the nearest dollar. So the 80 cents is actually going to round this up to a 9. So $20,729 is what should be put in the bank today. And then on to another one where it's very similar to what I did in the lecture part. So I did this one, except I had it divided right here, and I had this as a 300. And I think I just had this as just e to the negative x instead. So basically, the company is introducing a new product to as many people as possible through television. Oh my gosh, this is old. What? Who watches television? Anyway, just make that your phone. Advertising, and there's 3 million, so this is actually in millions. Graph the function between 0 and 50. And then what does it look like? All right, so y equals, yeah, see, there's my example from the lecture part. So this one does not have divided, it just has 3 parentheses, 1 minus, and then the e function raised to a negative 0.048, and the calculator likes to use x instead of t, but that's fine. And graph it for t, or us x, between 0 and 50. So if I go to the window and I go from 0 to 50, and this, I think, is only going to get to 3. Look at that's 3.5, that's 3.5. So on the y values, I'm going to go from 0 to, they go to 3.5. So I'm going to go to 3.5. And then just look at the graph, and which one does it look like? It doesn't look like that one. The shape is like that one, but this one is moved up. Oh, it's that one right there. There we go. And then on to another one that I did not do in the lecture part. And this is important. So this is basically, they have all of these years, and then they have the mobile data, which exabytes per month. So basically how much data is being used. And an exabyte is 10 raised to the 18th, which is a huge number. But that's okay, because these are just in decimals, they're fine. And then they say write a regression equation for this. So once you do this once, you're going to go, oh my gosh, that's so easy. So eventually we're going to be looking for this type of function, but the first thing I need to do is type this into the calculator. So if you go right here to stat for statistics, and you choose number 1, edit, then it will give you lists, L1, L2, L3, etc. If you're looking at your calculator right now and somebody okay, hold on, I need to get to the top. So when you have a list and you want to clear it out, because this is left over from some other class, then you use clear. And then when you move the cursor, now it's cleared out. But if somebody on your calculator accidentally used delete and they actually deleted the lists, then you don't have any list names. So if that happened, just go to stat and number 5 will reset it. So you just put that, hit enter. Now when you go to stat, then the lists are back. And I'm going to put these in the X's, and these, or excuse me, this in list 1 and this is list 2. So these are the X's and these are the Y's. I also need to just look at the directions again. And in here, their questions actually use the year 2015, 28, 2020. So I do need to type the whole thing. I can't just like take a shortcut and say, put a 15, put a 16, put a 17. They are using the whole year. Okay, so we have 2015 and 2016 and 2017 and 2018 and 2019, and then the dreaded 2020. And then type in these 3.9, 6.5, 9.8, 15.5, 23.0, and 31.8. And then they do need to be paired up. So for example, the 16 is across from the 6.5 and the 16 is across from the 6.5. So just make sure that they are in the same order as over here. Okay, now we need to do this part, and the calculator will do this for us. So if you go to Stat and then move over to Calculate, then starting right at number 4, they do the regressions for us. And there's lots of types of regressions. In other words, it's trying to find the function that fits the data the best. And in the homework, they said use this one. So let me see if I can find that one. So it doesn't, on the calculator, it doesn't write it like that, but this is exponential because the b raised to the x is an exponential function. So then I can use what's number 10, the exponential regression. And then the calculator is just asking you, all right, do you have the x's in list 1? So let's say that somebody messed that up on your calculator and it does not say list 1. Well, the names of the lists are under the numbers 1, 2, 3, 4, 5, 6. So right here, it says L1, but it's in blue. So I then have to put second L1. And then that 8 is going to mess it up. So I should have actually cleared it out first and then put second L1. And then this needs to be L2. And everything else you could leave blank, just go down to calculate. And something went wrong. I don't know what went wrong. So my lists are there, list 1, list 2. And then, sorry, this has not happened before. Exponential regression. Let me try power regression. Okay, I'm gonna have to pause the video and see what happened. Okay, I figured out what happened. So for some reason, the calculator does not like having all of these numbers. So as I mentioned sort of at the beginning, instead of putting 2015, you could just put 15, 16, 17, etc. So when I go back to the list, and then I put 15 and 16 and 17 and 18 and 19 and 20, instead of putting the whole 20, 15, 20, 16, then it works. So then I go to Stat, move over to Calculate, and then do the exponential regression. And this is still list 1 and list 2, and then Calculate, and then the calculator's happy. So what it's saying is the function is going to be y equals, first you put the a, so 0.007, and then you put the b, which is 1.524, and then it's raised to the x. And in this class, we don't use the r squared or the r, just ignore those. So that's what they're asking for right here. And then estimate the mobile traffic in 2028. So because I did not use the 20, then I just need to plug in x equals a 28. So then just use this and plug in a 28 right here. So 0.007, and then 1.524 is raised to a 28, and then it would grow exponentially until it's 930.416. And then you do have to watch out for things like this. It says round to 4 decimals. So what I'll need to do is go to the mode and change my float to 4 decimals. And then just redo that problem, which I don't feel like typing it again, so I'm just going to copy it. And okay, so instead of this being a 6 at the end, it should be a 5.9 if you go to 4 decimals. All right, next up, number 17. which is not a difficult problem at all, but basically they're saying this is the exponential form. What if you write it as a logarithm? So when you write it as a logarithm, you write log, and then whatever the base is, you put that at the base of the letter G. So the 5 goes down at the base of the letter G. And when you do a logarithm, whatever's over here, that's the exponent. So the exponent was a 3. And then you would substitute a 125. So that's the logarithmic form, just like that. And basically, this is number 20. It's saying simplify this. So since this says log base 6, and this is a base of 6, these two can cancel each other out, except the r is blocking the way. So what you can do is use the rule of logarithms that says if you have something that's multiplying right here, you can move it up here and use it as an exponent. So that means it's u to the r. So once this becomes u to the r, then the 6 and the log base 6 cancel each other out. So that's just u to the r. And for one more, this is number 24. And so for this one, I'm going to do the same thing. You can take this number and move it up here as an exponent. So the 25 is going to have an exponent of 1/2. Now it's going to take care of this 1/2. And then this 2/3, you can move it up here and use it as an exponent on the 64. And that takes care of the 2/3. And then what I can do is the left side is going to say log base b of x equals, and then I have log base b, and then this is saying take the square root of 25, or in other words, 5 raised to the 1/2, oh sorry, it was 25. 25 raised to the 1/2, last try, 25 raised to the 1/2 means the square root, so that's a 5. Boy, it was harder to use my calculator than to use my brain. And then this one is saying take the cube root of 64 and then square that answer. Or take 64 and raise it to the 2/3, and then that's just a 16. So this one did say plus. So plus log base b of 16. And then this one, I just copy it down. Minus log base b of 20. So now we'll use the rules for logarithms that you can combine logarithms. So I can combine the first two, log base b, and since these are added, that means multiply these two numbers. So whatever 5 times 16 is. And when it's subtracted, that means you divide by this number. And on this side, it's just going to say log base b of x. And now that log base b is on both sides and there's nothing in the front and it's all been simplified, log base b and log base b cancel each other out. So we get x equals 5 times 16 divided by 20. 5 times 16 divided by 20. And that's a 4. Type an integer or simplified fraction. That's an integer.